Welcome to my channel, guys. Learning platform for engineers. So today we are going to learn shear reinforcement in the beam. Nominal shear reinforcement. It is the first step of our shear reinforcement in the beam. So here is the tau v vu b into d. Basically, tau v is the shear stress, nominal shear stress, or shear stress in a nominal. So here is Vu. V is also called as the shear force. Shear force. Vu is the shear force. B is the width of the beam. Width of the beam. Here D is the effective depth, not the overall depth. Small d. We denoted the small d for effective depth and capital D for overall depth. So our second step is the permissible permissible stress in a concrete. So permissible stress in the concrete denoted by tau c equals to as into 1000 divided by b into d. Here as is for the number of bar provided, number of bar provided. So as number of the bar provided, b breadth of the width of the beam, and d is the effective depth of the beam. So our third step is the maximum shear stress in concrete. So maximum shear stress in the concrete denoted by tau c max equals to 2.8 Newton per mm square for M20. Here we go again. Tau V nominal shear reinforcement from page number 72 of IS 456. This is the equation number 1. Tau V is equals to Vu upon B into D. Here is the our second equation. Tau c means permissible stress in the concrete, and here is the our third. Tau c max means maximum shear stress in the concrete. So our fourth step is to compare equation 1 and 2 and 3. So basically, if the equation follows this, tau c max is greater than tau c and tau c is greater than tau v, means nominal shear stress is less than shear stress in the concrete is less than maximum shear stress in the concrete. So if this condition satisfied, then no shear reinforcement required. And as if if the if our fifth step is, if this equation is not satisfied, then again compare. This is the b and our above equation is the a. Again compare. So if you got this equation, tau c max is greater than tau v and it is greater than tau c. So basically, permissible stress in a concrete is less than tau v, means nominal stress in a concrete is less than tau c max, means maximum stress in the concrete. Here we provide the shear reinforcement. Shear reinforcement. Here we provide shear reinforcement. So to find the how much shear reinforcement required, the VUS, our six steps, find required required shear stress. Find the required shear stress. So it is denoted by VUS. U means ultimate shear stress in the steel, or in the shear, sorry, steel, not, it is not steel. Ultimate shear in a stress, ultimate shear in the, yes, is the, what we called it, uh, shear. So ultimate shear is equals to VU, means maximum shear, minus VUC. So VUC means maximum stress in a, sorry, VC only, shear force in the concrete. So our next step is VS or VU or VUS is equals to shear required required shear force. Required shear force. VU is the maximum shear force, and VUC means shear force taken by the concrete. So VUC means tau C into B into D. Tau C means permissible stress in the concrete, into B width of the beam, and into D effective depth of the beam. So here we got VUS. Our seventh step is to find spacing and shear reinforcement. Shear reinforcement. So how we find the spacing in the shear reinforcement? Basically, VUS is equals to 0.87 FY ASV into D divided by SV, and we assume the ASV equals to ASV, basically this term. We assume the ASV like, uh, for example, 8 mm maximum. We provide 8 mm diameter of the for the stirrups. So area of vertical stirrups, this is area of vertical stirrups, generally we provided 8 mm. So VUS, find from this equation maximum shear force minus shear force taken by the concrete, and here we got the spacing SV from transfer of this formula to VUS in denominator, and SV into, uh, for opposite side, transfer to the opposite side. SV basically, uh, minimum or maximum size give from the IS Indian standards is basically shear, sorry, SV means spacing for the vertical stirrups does not exceed 300 mm, and also 0.75 D. D means effective depth of the beam, and this is the first This is second, and third is the ASV upon B into SV equals to 0.4 upon 0.87 Fy. This value from ASV, and B is the width of the beam, SV is the spacing for vertical stirrups, 0.4 is the constant value, 0.87 is the basically 0.87 Fy means grade of the steel, and 0.87 for shear. This is the constant value, 0.87. Thank you, friends.